Let's take a look at solving problems dealing with fundamental theorem of algebra with the help of the TI-89 calculator. I'm not going to use a cast feature that could potentially give us all the answers, but I'm just going to use the same functionality that you see on a TI-3, TI-4. Now on my website, www.mathheals.com, if you go to graphing calculators and click there, you can click college algebra, and these are all the different functions you can do on the graphing calculator in college algebra. And I'm going through and creating these for every calculator slowly. Okay. If you need help on a particular topic, you can go to Math Lectures, go to College Algebra, and then you click on whichever topic you're struggling with. For example, if you're struggling with quadratic equations, click the YouTube video link, and you can watch the same lecture I give in the classroom, same explanation, same example, same everything. Don't click on a WebEx video. I'll eventually remove those. Okay. Let's take a look at our first problem. It says find the zeros, which means we're going to set this equal to 0. So we've got x to the third minus 3x squared minus 18x plus 40 equal to 0. Now, one of the things fundamental theorem of algebra tells us is our power, when you're dealing with a large power, when you're dealing with polynomial, that's our degree, tells you how many answers you have. So we're going to have 3 answers. Now we're going to put this on our y1, and we'll put this on our y2. So let's go do that. I'm going to go to y equals, so do diamond F1. Up arrow to y1, I'll press clear, and I'm going to put my x to the third, so x caret 3 minus 3x caret 2 minus 18x plus 40, enter, and then put a 0 on y2. So you have to have 0 on y2. Okay, well, let's go graph now. So I'll do diamond F3. Now, our zeros is where it crosses or touches the x-axis, so I can visually look at these and see 1, 2, 3, -4, 2, and 5. But let's see how to use the functions on the calculator, because they're not all so easy you can just look at them. You see F5 says math, so if I press F5, brings up this this menu. Now I want to choose intersection, which is the 5th one, so I'll press 5 on that. Now it says first curve, so I'll do enter. It says second curve, so I'll do enter. Now for lower bound, I want to find this one over here, so I'm going to go and do my left arrow key, and I want to move my cursor to the left of the answer, like right there, and then press enter. Asks us for upper bound, so I'll move my cursor to the right of it and press enter. And it comes back and tells us the intersection, XC, is -4. So our first answer is -4. Well, we got 2 more answers. We need to go through the process 2 more times. So I'll press F5 for math, choose 5 for intersection. First curve I'll do enter, second curve I'll do enter, and lower bound, I'm going to go over here to the right. I want to be to the left of this answer, which there is fine, so I'll press enter. Now for upper bound, I want to go to the right of where the answer is, which there is fine, so I'll press enter. And tells us our second answer is 2. Now if I press F5 again, you notice that there's actually a 0 function here. If I choose 2 for 0, see it says lower bound. Well, my cursor is down here at the very bottom of the screen, kind of hard to see, but if you press your right arrow key, we want our cursor to be the left of where our answer is in terms of the x values. So that's the left of it, so press enter. Now upper bound, we want it to be the right of where our answer is, which is there. You press enter. And see, it comes back and tells us 5. Now that may seem like, well, that's a little bit easier than the other one. I like the other one for 2 purposes, and that's why I'll stick with that one. Is the first purpose is it matches the intersect method that I show in class, because I demonstrate the intersect method on TI-3, TI-4. Also, it's a little easier to see left and right of the answer when it's not tracing the graph. So let me go through that again. So I'll do F5, and this time I'll choose intersection. Okay, first curve inner, second curve inner. Lower bound, I want my cursor to the left of where my answer is. Well, this is our answer, so that's the left of it, so I'll press enter. And for upper bound, I want it to the right of it, which there is fine, and then I'll press enter. Comes back and tells us the same thing, x equals 5. Now the largest power is the third power. We said we're going to have 3 answers, and we just found all 3 answers. So we're done with that problem. Let's take a look at our second one. Want to find the zeros again, which means we're going to set it equal to 0. So we got 4x to the third minus 17x squared plus 16x minus 3 is equal to 0. Okay, we're going to have 3 answers again. I'm going to go back to my y equals, so I do diamond F1. Up arrow to y1, I'll press clear. And then we'll put 4x to the third, so 4x caret 3 minus 17x caret 2 plus 16x minus 3, and press enter. Excuse me. And we already have 0 on y2, so that's fine. You don't have to re-enter it. Let's go graph now. I'll do diamond F3. And looks like, I don't know what that is actually. Anyway, I'll choose F5. Choose intersection, so press 5. Now first curve, inner, second curve, inner. I want it to be to the left of the answer I'm trying to find. I'm trying to find an answer right here. That's the left of it. So press enter. I want to move to the right of it. And I'll move right there. I'm in between those 2 answers. And then press enter. And we get 0.25. Well, we don't want decimals. And you see how this is XC? I'm going to exit out. So I'm going to do second escape. Now if I do XC, I do my X key, and then alpha, and then close parentheses for the C, and then press enter. You see we got 0.25. Now, for the 0.25, to change that to a fraction, there's different ways of doing it. If you have your mode set up correctly, if I did mode here, and then I go to page 2, so I do F2. You see down here exact, approximate. If I do a right arrow, and instead of auto, if I have it set to exact, and press enter, and then enter again to save it. Now if I do XC, you see we got 0.25, but then it tries to convert that to this. Well, that's rounding issues that's come up. That 0.25 it's showing you is an approximate. So there's a little bit of a flaw with that. If you just come over here, and if you just typed in 0.25 and pressed enter, you would see your 1/4. So it's not as I don't like this as well as the TI-3, TI-4, where it just gives it to you directly. It handles the rounding perfectly. But our first answer is 1/4. I'm going to set this back to auto. I really don't like that exact because of this this right here. There's another calculator that does that, HP prime. It will give you, it tries to be too accurate. So press mode. I'm going to do F2 for page 2. And exact, right arrow, and I want to choose auto, so I do 1. And then press enter to save that. Okay. And again, if I were to come up here and choose XC and press enter, you see we just get our 0.25 because that's a numerical approximation. So not perfect. Now it's possible that you may have a different problem that converts just fine to a fraction. When you do an XC, it comes up with what it should be, but not in this particular example. Okay, let's go back to our graph. Do diamond F3. It looks like our next answer is 1, but let's do F5. choose 5 for intersection, and enter our first curve, enter our second curve, and that looks like to the left of that answer, so that's good. I'll press enter. Upper bound, I'll go to the right of it and press enter. And that gives us x equals 1. Okay, now let's do this one. So I do F5 and choose intersection. Enter our first curve, enter our second curve, lower bound, I want to be to the left of it, let's say right there, press enter. And upper bound, I want to be to the right of it, right there, and press enter. And again, our answer is where it crosses the x-axis. And that gives us 3. Just out of curiosity, because I haven't played with the zero function that much on a TI-89, let's see if it gives us the exact answer there for this first one we tried to find. So let's do F5, and I'll choose 0, so 2 for 0. Lower bound, I have no clue where my cursor is even at. That's what I don't like about this sometimes. There it is. It's tracing. And I want to be to the left of that answer in terms of max values. That's the left of it, so press enter. Now upper bound, I want to be to the right of it, and that'd be fine there. Press enter. Okay, we got 0.25, and that's not promising. Look at the y value. That looks like some error that's accumulated there. So let's see what the XC looks like. I do second escape, and I already got XC highlighted there, so that works out nice. 0.25. Okay, it's no better. I've never had much luck with the zero function on calculators in terms of getting better results. Usually I get better results with the intersect. Okay, let's take a look at our third one. We want to find the zero, so we're going to set this equal to 0. So we got x to the 4th plus 5x to the 3rd minus 5x squared minus 15x plus 14 equal to 0. Okay, I'm going to go back to my y equals, so I do diamond F1. I'll up arrow to y1, press clear, and then I get x to the 4th, so x caret 4 plus 5x caret 3 minus 5x squared minus 15x plus 14. And I press enter. Let me double check that. X to the 4th plus 5x to the 3rd minus 5x squared minus 15x. I'm using my right arrow key to scroll over. Plus 14. Okay, that looks good. Now I'm going to go to my graph. So I do diamond F3. Now let's find this first answer right here. You can't do anything while still doing the same busy, so it's done. So we do F5. Choose 5 for intersection. I'll do enter on first curve, enter on second curve, lower bound. I'm going to hold down my left arrow key. We want to be to the left of this answer. So that's the left of it, so I'll press enter. Upper bound, we want to be to the right of it. That's to the right of it, so I'll press enter. Negative 5.31662. Okay, and that's an XC. So if I exit out, I do second escape. And if I type in XC, it already says XC there, but if yours doesn't, you do X key, alpha, closing parentheses for the C, and press enter. Doesn't change to a fraction. I could go and change my mode to exact, and that's what you have to be careful of if yours says exact, is it'll try to change that to a fraction for you. Let me show it just for fun. Mode, F2 for next page. Come down here, I'll right arrow, and then I want to do exact, so down arrow to exact and press enter, enter again. And now if I do that, you see we get this. This is the problem of having exact on, is even on approximations it tries to convert those to fractions. That's not our answer, by the way. So I'm going to go back to mode, F2, exact approximate, right arrow, and I want to choose 1 for auto, and then enter to save. Okay, we can't use that answer. Wouldn't change, and obviously it's not something we recognize. Let's see what else we have. Diamond F3 for graph. Looks like -2. So I'll do F5 for math. I want to choose 5 for intersection. Inner on first curve, inner on second curve. Lower bound, I want it to be to the left of the next answer. I don't want to be too far away though. So that's good right there. That's the left of it. Press enter. For the upper bound, I want to be to the right of it. And that's good right there. So I'll press enter. And that tells us x is equal to -2. Okay, well, let's continue on. Looks like the next one's 1. Now, this may be a little tricky to get to the left of it and to the right of it. And that shows sometimes a flaw of this. Whether you're using a zero function or the intersect method, it's still the same problem. Okay, so I'm going to do my F5, choose intersection, 5, and first curve inner, second curve inner. Lower bound, I want to be to the left of it. That's probably good right there. Upper bound, I want to be to the right of it. Let's see what that gives us. Press enter. Gives us 1. I'm surprised. We got another answer there. So I'm going to do F5. The reason I know that is if I move my cursor off that, see how the graph is going down a little bit below the x-axis? So that means it's going down and going back up. Well, if I do F5 again, and then choose my intersection, inner on first curve, inner on second curve, I want to be to the left of that answer. Right there would be left of it. Press enter. Upper bound, I want to be to the right of it. Well, that's to the right of it. Press enter. But we get x equals 1 again. That's no good. Those answers are so close together that it'd be hard to figure out left and right of it, whether you're using a zero or whether you're using the intersect method. This is where the zoom comes in nice. If I do F2 for zoom, I'm going to choose zoom box. That's one I like the best. So I'll press enter on zoom box. I want to put this in my upper left hand corner where I want to drop my box. So I'll do my up arrow, left arrow, put it about right there. Press enter one time. And then the second corner, this is our lower right hand corner. So down arrow and then hold down my right arrow, and that'd be good there. Okay, so now graph's come down. I can see it better now. This will be easier to work with. If I do F5 for math and choose 5 for intersection, inner first curve, inner second curve, lower bound, I want it to be to the left of that answer, which is right there. Press enter. Upper bound, I want to be to the right of it, which right there would be to the right of it, and press enter. 1.31662. That does not look promising. Doesn't look like something that changes to a fraction. If I exit out, do second escape, and if I would type in XC, it already says XC, so I'll go ahead and press enter. Doesn't change to a fraction. So yeah, we'll go with what we have. Now I'm going to go back to my graph. I do diamond F3. I've zoomed, so I want to set it back. So I do F2 for zoom, and I'm going to choose zoom standard 6. And that'll set your your graph back to standard viewing window. Okay, let's wait until it finishes before I go away from it. There it goes. We found 2 answers via our calculator. Well, we're going to plug these into synthetic division. So I'll put -2 in first. So I got 1, 5, -5, -15, and 14. Remember, this is x to the 4th here. So add, multiply, add, multiply, add, multiply, add, was that 7? Multiply, -14, and we get a 0 here. You should get a 0 there. If the calculator told you it's an answer, you better get a 0 there. So that means that's our first answer. Now, we went from x to the 4th, we're now down to x to the 3rd. And we're going to plug in our other answer. So plug in 1. And we'll add, multiply, add, multiply, add, multiply, add, and we get another 0, which you should. Calculator told you this is an answer. You better get a 0 there. Okay, now this went from x to the 4th, x to the 3rd. We're now down to x squared. And this is x, and this is no x, our constant term. So we're left with x squared plus 4x minus 7 equal to 0. And we have to use a quadratic formula. So a is the numbers in front of our x squared, which is 1. b is the number that's in front of our x, which is 4, and c is our number at the end, which is negative 7. Quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. So we're going to have x is equal to, it's probably a good idea if you mess up on signs to go through and replace your variables with sets of parentheses before you plug in your numbers. So I'm leaving everything the same, I just replaced my variables with parentheses. Now we said b was 4, so everywhere I had a b I'll put in 4. We said a was 1, so everywhere I had an a I'll put in 1. And we said c was negative 7. So that gives us negative 4 plus or minus square root. 4 squared is 16. Negative 4 times 1 is negative 4 times negative 7 is positive 28 over 2, which gives us negative 4 plus or minus square root. 16 plus 28 is 44 over 2. You should always simplify your radicals whenever you can. 44, if I do the prime factorization, is 2 times 2 times 11 over 2. Remember, with square roots, we're looking for pairs of something. Here's a pair of 2s, so the pair of 2s is going to come out in front as a single 2. And we got negative 4 plus or minus 2 squared 11 over 2. Remember, if you can divide this number, and this number by the same number, do so. Well, those are all divisible by 2. So that's going to give us negative 2 plus or minus 1 squared 11 over 1, or simply just negative 2 plus or minus squared 11. Calculator gave us 2 answers, and then we found the other 2 after we did synthetic division and quadratic formula. So we got our 4 answers. The plus or minus here is why we have 2 answers down here. The reason why they were decimals that wouldn't change to fraction is that they were actually radical answers. Okay, let's look at our last one. Want to find the zeros again, so we'll set it equal to 0. So we got x to the 4th minus 6x to the 3rd plus 30x minus 25 equal to 0. Go plug this in the calculator and see what we can find. So I'm going to go to my y equals diamond F1. Up arrow to y1, press clear. Then I got x caret 4 minus 6x caret 3 plus 30x minus 25. Enter. Now go to graph. So do diamond F3. Looks like negative 2, but it's not exact. I'm thinking it probably won't even change, but let's see. If I do F5, choose 5 for intersection. Enter our first curve, enter our second curve. I'll do my left arrow key here to go to the left of that answer. Again, our answer is where it crosses the x-axis. Press enter one time. Upper bound. I'll do my right arrow key to go to the right of it, and then press enter. Negative 2.23607. You could probably guess this wouldn't change to a fraction. If I exit out and try to change it, it doesn't go anywhere. Looks like our answer here is 1, but let's verify that. Let's do F5. Choose 5 for intersection. Enter our first curve, enter our second curve, lower bound. I want to be to the left of that answer, which right there is fine. Press enter. Upper bound, I'll do a right arrow, and I want to be to the right of it, right there, and press enter. And we get x equals 1. Well, let's see what else we got. Looks like 2. So I'll do my F5 again. Choose 5 for intersection. Enter on first curve, enter on second curve. Lower bound, that's to the left of it, so press enter. Upper bound, I want to go to the right of the answer, right there, and press enter. 2.23607. We could try to change it, but that's pretty obvious. That's not going to go anywhere. So let's find this next one. So I'm going to do my F5, choose 5 for intersection, Enter our first curve, enter our second curve, lower bound. I want to be to the left of that answer, which right there is fine. Press enter one time. Upper bound, I want to go to the right of it and press enter. And we get 5. Okay, well, we got 2 answers. It'd been nice if we got all of them, but we take what we get. We'll take our 1 and we'll plug it in synthetic division. So I got 1 here, -6, 0, 30, -25. I see more people mess up on this and these problems. Our largest power is x to the 4th, so we're going to have an x to the 4th, we'll have an x to the 3rd, we'll have an x squared, we'll have an x, and we'll have a no x, or constant term. If you write these across the top, starting with your largest power, and then 1 for each one going down, you will never miss that 0 that should be there. Because we're missing the x squared component, so we had to put a 0 there. Now I get lazy myself. You notice in the one up above, I didn't do that. And so sometimes I do miss a 0 myself. Always put that across the top if you find you are making mistakes like that. Okay. Add, multiply, add, multiply, add, multiply, add, multiply, add, and we get a 0, which you have to. Calculator told you is an answer. Well, we start out with x to the 4th. We're now down to x to the 3rd. And we want to plug in our second answer on the line we just found. So we continue this process. So we'll add, multiply, add, multiply, add, multiply, add. And we found another 0, so that's our second answer. Now, this was x to the 3rd, so now we're down to x squared, and this is x, and this is no x, our constant term. Now, when you're missing the 0x like that, this becomes x squared minus 5 equal to 0. I didn't mention it up above, but why do we set it equal to 0? Because we're finding zeros. You're always setting it equal to 0. When your middle term is missing, this is a perfect example of the square root property. So if I take the -5 over, it gives us a positive 5. And square root property says if you got something squared equal to something else, you drop your squared, and you put a plus or minus square root on the other side. And actually, once we're done with that, those are our other 2 answers. And again, the reason why they were decimals that would not change the fraction is they were actually radical answers. Okay, let's take a look at one more example. This is one that causes headaches on some calculators. And let's see how the TI-89 handles it. I'm trying to find the zeros of this. So we're going to set the x minus 2 squared equal to 0. And let's see what it looks like. So go to my diamond F1 for the y equals. Up arrow to y1, press clear. Do beginning parentheses, x minus 2. Closing parentheses, caret 2. Enter. And then I'll graph. So do diamond F3. Looks like it comes down and touches a 2 and goes back up, which kind of corresponds to our shifts. Remember when numbers inside with the x, it shifts to left or right, opposite what you think. So -2 makes us think it goes left 2, so it goes right 2. Well, let's try to find our intersect. So I'll do F5, and then I'll choose 5 for intersection. Enter our first curve, enter our second curve. Lower bound, I want it to be the left of where the answer is. That's the left of it. Now press enter. Upper bound, I want to be to the right of it. So I'll do my to the right of it and press enter. Worked perfect. Gave us 2, which is what it should. TI-83, TI-84 struggles with that particular one. Now let me try the 0. I'm just curious. F5, I want to choose 2 for 0. Lower bound. I want to be to the left of where the answer is, so keep doing my left arrow key. Here's where my answer is. That's the left of it. So press enter. Upper bound, I want to be to the right of it. So move up there. Press enter. Found it again. Excellent. So we get x equals 2 from the calculator. Now that was how to solve problems dealing with the fundamental theorem of algebra using the TI-89 calculator. To exit out of this, you do second escape.